In this video, we're going to look at graphing a line using its intercepts. So the first thing we want to do is talk about what the intercepts are, what we mean by intercepts. So let's take a look at this graph. Here we have the graph of a line. So here, let's say this is a linear equation, all right? And we have our x and y axis that we are familiar with. Now, if the line is oblique, which it is in this case, in other words, it's not horizontal, vertical or horizontal. If it's oblique, then it will touch both the y-axis and the x-axis. It will intersect at some point. All right, so let's think about what the coordinates of that point would be. Well, the x-coordinate is moving left and right. It's not moving left and right at all, is it? So it's going up over 0. Now the y-coordinate is going to be whatever this y value is, right? It's going to be this distance, whatever this distance is. And it could be negative. It could be below the x-axis as well. All right, so let's just call this value b. All right, so let's say this is up b. It's some variable. I don't know what it is, okay? So in other words, this value is up b. All right, similarly with the x-intercept, let's go over here and think about what the coordinates would be over here. Well, it's going to go over some amount. Could be left, could be right. In this picture, it's to the right. We don't know how far, so let's call that a. And it's up 0 every single time that the line intersects the x-axis. The y value is going to be 0 because it's on the x-axis. So we're going to take advantage of the fact that we have a 0 for the x value in our y-intercept and a 0 for the y value in our x-intercept to graph lines in a quick, easy way. So let's say we have the equation of a line. Let's do 2x plus 3y equals 12. All right, and let's say we want to graph this. Now, you may know how to graph this by putting it in slope-intercept form or making a table of values, which is kind of what we're going to do. We're going to make a table of values, but we're going to be very specific about which points that we want to find. We're going to find our intercepts. So we're only going to do 2 values here, right? We're going to let x be 0, and that's going to tell us our y-intercept. And then we're going to let y be 0, and that's going to tell us our x-intercept. Now, the advantage to doing this is arithmetic with 0 is pretty easy, right? So let's do our y-intercept first. All right, so to find our y-intercept, we're going to let x be 0. So I'm going to take the equation 2x, but instead of x, I'm going to put the 0, plus 3y equals 12. So that gives me 0 plus 3y equals 12. And then, of course, if I divide both sides by 3, or I could do this in my head, 3 times what is 12? The answer is 4. All right, so my y-intercept is at 0, 4, which is right here. Now, I showed a lot of work there, but really, I mean, you could just think, okay, if x is 0, this whole term is gone. So just picture that this 2x term is gone, and you're just left with the equation 3 times what is 12? That's 4. I mean, you really don't have to write all this. You can kind of do it in your head, which is the nice part of using intercepts to graph. All right, let's do the same thing with our x-intercept. So to find our x-intercept, we're going to write our equation, except we're going to let y be 0. Oops, that should be a 2. Make sure we copy stuff down, right? Plus 3 times 0 equals 12. So we just end up with 2x equals 12, and if we divide both sides by 2, we get x equals 6. So my x-intercept is at 6 over 6 up 0. My y-intercept is over 0 up 4. So these are special points on my line, right? I have infinitely many points on my line, but these are 2 special points, and now I can use these 2 special points to graph my line by just connecting these. Let's see how straight I can get this. That's not bad. I won't go any further than that. A ruler would be nice. And boom, we have the equation of our line. All right, let's have you try one Using the intercepts now, I want you to graph the equation. Let's do negative 4x plus y equals negative 8. All right, so I want you to set up a little xy table over here. You're only going to have 2 points in your table. 1 point, the x value is going to be 0. 1 point, the y value is going to be 0. Figure those points out, plot them, draw your graph, and you can pause the video and then unpause it when you're ready to take a look. All right, how did you do? You should have got 0, negative 8 for your y-intercept and 2, 0 for your x-intercept. All right, if you plug those values in, you'll see that they work. Watch your negatives there. You got to make sure all your negatives are working out. And then we just connect these 2 points and we have the graph of our line. Now, when we're connecting those 2 points, we are getting infinitely many points, right? So let's just take a look at some other points we've got. We've got this point on our line. I'm finding nice ones, obviously, like this point's on the line and this point, but I want to find some I can easily see the coordinates of and not estimate. So this looks like it's over 3 up 4. Now this is a cool way you could test. You could come over here. If you put 3 in for the x and 4 in for the y, it should work, right? It should still be a solution. Let's try it. If I do this, does it equal negative 8? Let's see, we've got negative 12 plus 4. Yeah, that equals negative 8, right? Nice. You could try this one. That one should also work. That looks like a nice one. There are lots of points on the line. You could find values of x and y that work. You could find infinitely many values of x and y that produce a result of negative 8. Again, what's the benefit of the intercepts? You're using 0 for one of your variables, and that makes the arithmetic so much easier. It only takes 2 points to determine a line, and these 2 points are the easiest ones to find.